Hello everyone. Welcome back to AWS Cloud Practitioner Certification Bootcamp series brought to you by CloudExpert Solutions. Today we are covering a must-known topic for the exam, AWS Cloud Value Propositions and Global Infrastructure. If you are preparing for the exam, this is a must-known topic and you should know this by heart. By end of this video, you will understand why businesses or organizations choose cloud. You will also understand AWS global infrastructures like regions, availability zones, edge locations, wavelength locations, and local zones. Also, key benefits like high availability, elasticity, agility, fault tolerance with real-world examples. On behalf of the CloudExpert Solutions team, I would like to thank you for joining us and exploring this video. If you have already subscribed to our channel, thank you from the bottom of our hearts. It truly means a lot to our team. If you haven't subscribed yet, we kindly invite you to do so and gain access to premium cloud courses and certification bootcamps all for free. This is a high weightage topic, so please pay close attention. I'll also share exam tricks to remember key points. Let's dive in. Before we start the module, let's explain what is cloud computing. And to understand that, let's imagine you need electricity at home and you have two options. The old way, you buy and maintain your own power plant, and you know the implications. There will be huge upfront cost, wastage of energies because you need to run 24/7 even if you are asleep and you do not need the electricity. And most important, you need to fix every breakdowns, which will be expensive in nature. On the other hand, the other option, you just pay the electricity bill like other utility bills. There is no upfront cost. You pay only when you use or when you flip the switch. It scales instantly, need more power, just use it. And also it is maintenance free because the power company keeps the plant running. Now let's apply this concept for cloud computing. AWS is your cloud utility provider. Instead of building your on-premise data centers, just use AWS Cloud and turn it on or off when you don't need it. If you need servers, instead of purchasing those compute capacities or physical servers in your on-premises, use Amazon EC2s, which is a virtual machine. If you need storage, instead of using physical storage, use cloud storage and other 100 plus services all on demand, just like your other utility subscriptions. Unless you are Tony Stark or Iron Man, you probably don't want to build your own data centers after learning cloud computing. Do you know that over 90% of the Fortune 500 companies currently use AWS? You must be wondering why. What are the advantages of using cloud? To start with, cost savings. With traditional data centers, you buy servers upfront. Like purchasing a car, you will barely drive. With AWS, you pay as you go, like Uber for computing. As an example, if you need a server for 2 hours, instead of buying own server, you can use AWS EC2 on-demand mode because AWS virtual machines will cost you in pennies instead of spending in thousands. And if you stop using, the billing stop too. No more dusty servers in your data centers. The second advantage is agility. The old way of managing and maintaining data centers, when you order a server, you wait weeks for delivery and setup. However, in AWS, you can deploy a fully configured servers in 60 seconds, even faster than microwaving popcorn. As an example, if your boss needs a demo tomorrow, you don't have to sweat. You don't need to build or you don't need to order any physical server. AWS agility is your superpower. The third advantage is elasticity. Let's imagine your website can handle 1,000 concurrent users. However, during a promotional sale, 10,000 concurrent users are accessing your applications. your website will crash because of the traffic spiked. With AWS, auto-scaling capability will add servers automatically like magic. And when you don't need or when the traffic will go, additional servers will go away and you will pay only what you are using. As an example, Netflix scales to millions of viewers during any new release and then scales down to save cost. No more guessing how many servers you will need for that peak hours. The next advantage is high availability. With traditional on-premise data centers, if one server fails, your application crashes. But with AWS multi-AZ deployment, it will keep your applications running 24/7. As an example, Amazon.com uses multi-AZ databases. And let's assume if Northern Virginia goes down, then Maryland will take over instantly. And your users won't even feel this disruption. And this is the power of AWS Global Backbone. The last but not least, reliability. AWS services are bulletproof. Amazon S3, which is a storage service, stores your data in 3 plus geographic locations simultaneously. So even if two regions burn down, your dog names are still safe. As an example, Airbnb stores petabytes of listing photos on Amazon S3 with zero data loss since 2008. That means your data is safer in AWS than in your laptop's download folder or even in your data center. Now let's review AWS versus on-premises key differences. To start with, cost. You can trade fixed expenses for variable expenses. On-premises, like building your own power plant, there is a massive upfront cost even if you'll only need for a light bulb. However, for AWS, it's paying like the utility bill. You only pay what you use. Moving to our next point, massive economy of scale. AWS serves millions. That means it offers you bulk discounts that you could never get alone. The third advantage is no more capacity guessing. With on-premises, you buy all upfront. If you buy too much, it's waste of money. And if you buy too little, your application will not have enough resources to run. Whereas with AWS, auto-scaling adjusts the infrastructure based on the application load or traffic. Let's move on to our next advantage, speed and agility. In on-premises, if you need a new server, you need weeks to order and build, like you are waiting for an order delivery from other cities. However, with AWS, it will be ready instantly, maybe in 60 seconds, and it will be faster than microwaving popcorns. The next advantage is no maintenance. AWS handles all the boring stuff. That means no more server babysitting. You focus on your business, like how Uber does not repair their own cars. And last but not least, go global instantly. You want to reach worldwide? With on-premise, you need to build offices in every country. And you can understand how slow, expensive, and painful experience that will be. On the other hand, with AWS, you can deploy globally with just few clicks, like sending messages in your WhatsApp group with your global friends. Since we have reviewed all the cloud advantages, now let's review AWS global infrastructure. AWS has the largest cloud infrastructure in the world. As of June 2025, the AWS cloud spans across 114 availability zones within 36 geographic regions and 700 plus edge locations. AWS also announced and plans for 16 more availability zones and 5 more regions in New Zealand, the Kingdom of Saudi Arabia, Taiwan, Chile, and in European Union. AWS regions are separate geographic areas that AWS uses to host its infrastructure. These regions are distributed around the globe so that AWS customers can host their workload closest to them. Now you must be wondering how to choose an AWS region. Choosing an AWS region is like picking the perfect store location. When you select an AWS region, you have to consider a couple of factors like user proximity. You should pick a region which is closest to your customers. Why? Closer proximity means fewer network hops and lower latency, leading to faster application performance and a better customer experience. As an example, if your users are in Europe, choose Frankfurt, which is EU Central 1 region, over the Tokyo region. The next factor you should consider service availability, because not all services exist everywhere. You should check the AWS regional service list before selecting a region if that particular service is available in that region. As an example, AWS Ground Station is a service that enables you to control satellite communications. It is not available in South America, Middle East, and Cape Town regions. And if you think that you will distribute the services in multiple regions, then data transfer between the regions will cost extra. That is why you should keep the related services together. The next factor you should consider is cost and compliance. Service charges or price varies based on the regions. And here is an example where we have a side-by-side comparison of EC2 pricings, which is virtual machine in AWS between US East 1 and Asia Pacific Mumbai regions. And last but not least, you should consider SLA and the reliability. Before choosing any AWS region, you should validate if the selected region offers enough availability zones for your need. As an example, AWS US East 1 Northern Virginia has 6 availability zones, whereas US East 2 Ohio or US West 1 Northern California has 3 availability zones each. Talking about availability zones, let's understand what is AWS availability zone. An availability zone or AZ is a cluster of one or more data centers with independent power, cooling, and networking. Each AWS region has at least 3 availability zones designed to be physically separated by 100 kilometers or 60 miles or more to ensure fault tolerance. Availability zones within a region are connected through high bandwidth, low latency, and encrypted links. This design makes it extremely rare for 2 availability zones to fail at the same time. When you are building your application in AWS, always distribute them across multiple availability zones to ensure high availability. There is a common misconception that availability zones are same as data center. One availability zone may contain multiple data centers, but AWS gives you control up to the availability zones, not to the individual data centers. When you launch an EC2 instance, you choose the region and the availability zone, and AWS handles placement within the underlying data center infrastructure. Let's understand what is edge location. AWS edge locations are global site where AWS caches your content for faster delivery and reduce latency. These edge locations are connected to AWS region via a high-speed redundant backbone network. Let's understand with an example. Let's assume that we have one web application or the web server at Northern American region. Now you have customers globally, and let's assume that user 1 is trying to access the content from America, whereas user 2 is trying to access from Australia and user 3 is from South America. For the first time, when they will access the web page, all the static content, maybe the images, high quality videos, they will be accessed from the web server, and then AWS will cache this content to the edge locations, such that when the consecutive users will try to access that content, instead of fetching from the Northern America or from the web server, it will be served from the local edge locations, and it will reduce latency and it will provide an improved experience for your customers. Here is an exam tip. You should remember that edge locations are only for content caching. You can't launch EC2 instance or databases on any AWS edge locations. They are built purely to speed up the content delivery, not to host any virtual machines or any database servers. Next, let's review AWS local zones. When you need ultra low latency for applications like gaming or live video, AWS local zones is the solution. Local zones extend AWS services closer to large population centers for applications that require single digit millisecond latency. As of 2025, AWS has 33 local zones globally, and these are distributed across 17 locations in United States and 16 international locations including cities like Auckland, Bangkok, Copenhagen, Delhi, Hamburg, Helsinki, Kolkata, Lagos, Muscat, Perth, Warsaw and others. You can run virtual machines, databases, and network drives, but not all AWS services in these local zones. Getting confused with AWS availability zones and local zones? An availability zone is a cluster of data centers within an AWS region, while a local zone is a smaller extension of AWS infrastructure placed closer to users in specific cities to reduce latency. Have you ever noticed lag in your mobile apps? AWS wavelength zone can fix that. Now you must be thinking, what are wavelength zones? AWS wavelength zones embedded AWS compute and storage services within 5G mobile networks. Currently, AWS wavelength zones exist in 15 plus cities like New York, Tokyo, London. They provide ultra low latency in terms of 5 to 10 milliseconds. AWS wavelength zones are perfect for mobile gaming and live streaming, augmented reality, virtual reality experiences, and real-time factory robots. Now let's review benefits of AWS Global Infrastructure. AWS Global Setup gives you faster deployment. You can launch resources closer to your users. You can achieve high availability. If one availability zone fails, other will keep running and it will make your system or application available 24/7. And last but not least, global reach. You can serve customers worldwide with low latency. Throughout the video, we have frequently used terms like high availability, fault tolerance, elasticity, and scalability. Let's explore each of them in greater depth. High availability is minimizing downtime. As a real life example, like hospitals with backup power when the power grid fails, because you cannot disrupt power for all those intensive care units or ICUs. Similarly, with AWS multi-AZ deployments, if one availability zone in Northern Virginia fail, the other availability zone will take over. The next is fault tolerance. Fault tolerance is equivalent to zero downtime. Fault tolerance refers to a system's ability to continue operating properly even if one or more components fail. Just like a jet that can keep flying safely even if one engine stops working. A fault tolerant system is designed with built-in redundancy to handle unexpected failures without service disruption. In AWS Cloud, when you store data in an S3 bucket, it automatically replicated across 3 availability zones. This ensures that even if 2 availability zones fail simultaneously, a highly unlikely event, you will still have access to your data. The next concept is elasticity. Elasticity is automatic scaling. Let's assume you have a call center agent who can take 10 calls per hour. Suddenly, you started receiving 40 calls per hour. The system will clone your agent and automatically adds 3 more agents to match the demand. When the traffic drops, it scales back down. This ensures a smooth user experience without added wait time. Earlier we saw elasticity scale out by adding more agents. Scalability means boosting the same agent's capacity to handle more calls without increasing the number of agents. It's about doing more with the same number but with additional resources. That means it will grow in size. As an example, if you have a virtual machine with 2 vCPU and 2 GB of RAM, When more requests will come, you can upgrade that virtual machines to 4 vCPU and 8 GB of RAM. Now, these terms confuses many exam takers. That is why it's very important to understand the difference between high availability and fault tolerance. You should remember high availability is to minimize the downtime, whereas fault tolerance is zero downtime. During your exam, if you got a question which means no downtime, then think about fault tolerance. Another common exam mix-up is elasticity versus scalability. Elasticity is automatic scaling, whereas scalability is manual scaling. If the exam question asks automatically adjust the capacity, it is elasticity, not scalability. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at CloudExpert Solutions. You are now one step closer to crushing your exam. See you in the next module.